Every time you ask an AI to write an email for you or create some wild image, you're tapping into this hidden world of just immense power. So today, we're going to pull back the curtain on the absolutely staggering energy appetite of this AI revolution. I mean, think about it. You type a question, ask for a picture, whatever, and boom, in a flash, an answer just appears. It feels like magic, right? But what's really going on behind that screen? Where does that answer actually come from? Well, it's not just clever code and algorithms. You see, behind every single witty reply and every one of those stunning AI-generated images, there's a massive, invisible infrastructure that's just chugging a truly mind-boggling amount of electricity. So let's follow the energy. Okay, so where does this enormous energy bill even start? Well, it begins long before you or I ever type a single thing. It all starts with building the AI's brain from scratch. And this process, it isn't a sprint. It's more like an incredible computational ultra-marathon. It's kind of like teaching a toddler, Except instead of showing them a few pictures of a cat, you're basically force-feeding the AI billions of examples from all over the internet. It just churns through this colossal library of data 24/7 for weeks, sometimes even months, just to learn the basic patterns of how we talk and think. To get an AI to really understand and generate language like a human, you pretty much have to show it everything we've ever written. These large language models are fed huge portions of the internet. We're talking articles, books, websites, the whole shebang, just to build up that digital brain. Let's try to put a number on that. To train just one of the earlier models, GPT-3, just a single time, it was estimated to have used over 1,200 megawatt hours. Now that's a huge number, but what does it actually look like in the real world? Well, it's enough electricity to power 120 US homes for a full year. Just let that sink in. All of the power for a small neighborhood for 365 days, just to create one version of one AI model. And remember, that was for GPT-3. The models we're using today are way more powerful. Now, all that number crunching doesn't just happen up in some ethereal cloud. Nope, it happens in very real, very physical buildings. These are the digital powerhouses where AI actually lives and works. The massive, power-hungry factories of our time we call data centers. And inside these places, you've got thousands upon thousands of servers doing all the heavy lifting. But the real energy hog? It isn't just the computing. A lot of the time, half the entire power bill goes to one single critical task: staying cool. All those processors generate so much heat that without massive industrial-scale cooling, the entire facility would literally melt down. Someone put it perfectly when they said, these aren't just glorified server rooms. They are the literal backbone of our digital world. And it's true. They are the physical foundation for everything we do online, from sending a simple email to training the most advanced AI on the planet. And the scale we're talking about here is it's almost hard to wrap your head around. Back in 2021, Google's global operations consumed 18.3 terawatt hours of electricity. That is more power than the entire country of Lithuania uses in a year. And the main reason for that huge number? Their vast network of data centers. But here's the kicker. That super intensive training phase is just the beginning. The real story, the one that's unfolding right now, is the energy cost of actually using these tools every single day. This generative AI boom has created a completely new and continuous demand for power. Okay, so here's probably the best way to think about the two phases. Training, that's the one-time marathon. It's incredibly energy intensive, but it has a finish line. But using the AI, what the experts call inference, that's the everyday jog. Each individual prompt you make is pretty low effort, but it's happening millions of times a day, every single day, all over the world. And that's really the thing to understand here. Every single time you ask for a summary, generate an image, or get help with a line of code, you're making a tiny little withdrawal from the energy grid. But when you take all those tiny withdrawals together, the sheer volume of these daily interactions creates this enormous cumulative energy demand that's growing faster than anyone ever predicted. And if you want a sense of where this is all heading, get this. A new AI data center that's currently in the planning stages, well, it's expected to draw a full gigawatt of power. That is the same energy output as a typical nuclear power plant. All of that for a single data center. Now, I know this all sounds pretty alarming, right?
But it's a challenge that the industry is taking very, very seriously. So let's look at the path forward toward a more sustainable, greener AI.
The good news is people are tackling this from every single angle. On the software side, they're building smarter algorithms to get more results with less brute force computing. On the hardware side, they're designing these specialized low-power chips built just for AI. And then on the infrastructure side, there's a huge push to both power these data centers with renewables and to invent radically better ways to keep them all cool. And what's really driving this big push for efficiency? Well, it's both environmental and, frankly, economic. Electricity is one of the single biggest costs of running an AI business. So this creates a really powerful incentive, where saving the planet also happens to save a fortune on the electric bill. Look, we are just beginning to unlock the transformative, seemingly limitless potential of AI. The defining challenge of the next decade is going to be making sure its energy consumption isn't limitless, too. The question isn't whether AI can change the world, but whether we can power that change sustainably.